The browser is now the core workspace for professionals, but it's filled with repetitive, time-consuming tasks. From filling forms to copying data, these small inefficiencies drain productivity and stifle innovation. The demand for smarter, automated workflows is exploding, pushing browsers to become active partners in our work. Today, a new generation of tools is transforming tedious manual processes into efficient, automated operations. We'll explore three categories: cloud AI agents for conversational control, no-code browser extensions for accessibility, and code-based frameworks for maximum power. Let's dive into this automation showdown and discover which approach is right for you. First, cloud-based AI agents like ChatGPT Operator and Opera's Browser Operator interpret plain English commands and execute complex browser actions. Next, no-code browser extensions such as Browserflow and Automa let anyone automate tasks visually. No programming required. Finally, code libraries like Playwright and Puppeteer offer developers deep, programmatic control for robust automation. We'll compare these tools on performance, scalability, and integration. Real-world use cases and market data will reveal their strengths and weaknesses. Let the showdown begin. Cloud AI browser agents are redefining how we interact with the web, using AI to turn natural language into action. Tools like ChatGPT Operator and Opera's Browser Operator act as intelligent assistants. You state your goal, and they handle the rest. Imagine asking your browser to find hotels, compare prices, and summarize options, all in one command. These agents break down complex requests into actionable steps, eliminating the need for manual scripting. They adapt to new websites and ambiguous tasks, making automation accessible beyond developers. Developers can use them for quick data population or competitive analysis, saving hours of manual work. With a simple conversation, tedious tasks become effortless. How do these AI agents work? OpenAI's ChatGPT Operator uses visual analysis, capturing screenshots, identifying elements, and acting like a human. Opera's Browser Operator integrates directly with the browser, reading the page's code for faster, more private automation. OpenAI's approach is versatile, working on any site. Opera's is faster and keeps data local. Both can handle multi-step tasks, from booking tickets to filling forms, even across languages. When stuck, like with CAPTCHAs or logins, they pause and ask for your help, keeping you in control. This human-in-the-loop design balances automation with security. The result: powerful, flexible automation that still respects user oversight. Cloud AI browser agents shine in simplicity. Just describe your task and they automate it, no coding needed. They adapt to changing websites, but can be slow or unreliable compared to code-based scripts. Privacy is a concern for cloud models, and integration into automated pipelines is limited. These tools are best for personal productivity, not back-end automation. Real-world pilots like DoorDash and City Services show their potential to streamline user-facing processes. For developers, they're a quick way to offload repetitive tasks, freeing up time for complex challenges. The future AI agents as universal web interfaces, translating intent into action. Now, let's switch gears from the futuristic realm of AI agents to a category of tools that has been quietly empowering users for years: no-code browser extensions. These tools represent the robotic process automation movement brought directly into your web browser, providing a visual, user-friendly way to automate repetitive tasks without needing to write any code. Think of them as a powerful evolution of the simple macro recorder, but with added logic, data handling, and integration capabilities. We'll be looking at three prominent players in this space: Browserflow, which focuses on building visual flows; Automa, known for its intuitive flowchart-style workflow builder; and UI.Vision, a more robust tool that bridges the gap between browser and desktop automation. These extensions are designed to make automation accessible to everyone. The core philosophy behind these tools is to lower the barrier to entry, enabling non-programmers like marketing analysts, QA testers, or executive assistants to build their own custom automations. Instead of learning a programming language and wrestling with APIs, a user can simply record their actions, clicking buttons, filling in forms, navigating between pages, and the extension converts those actions into a repeatable script. This visual approach is incredibly powerful for rapid prototyping and solving immediate problems. If a sales team needs to extract lead information from 100 LinkedIn profiles, they don't have to file a ticket with the engineering department. A team member can build a simple scraping flow in an afternoon using one of these extensions. Browserflow, for example, is a Chrome extension that lets you construct automation flows by adding commands from a predefined list, or by using its recorder to capture your interactions. It excels at tasks like web scraping, where it can be configured to navigate through paginated lists, extract data from tables, and save the output directly to a CSV file or a Google Sheet. It even supports basic logic like loops and conditional statements, allowing for more complex workflows than a simple recording might permit. This empowers users to build surprisingly sophisticated automations that can handle variations in web page content and structure, all from within a familiar browser environment, which is a significant step up from purely manual repetition. Similarly, Automa takes a highly visual, node-based approach where you create a workflow by connecting different action blocks in a flowchart. One block might be open URL, the next click element, followed by a get text block, and so on. This makes the logic of the automation very easy to understand and debug. Automa's community-driven nature is also a major asset, offering a marketplace of pre-built playbooks for common tasks that users can import and adapt for their own needs. This collaborative ecosystem means you often don't have to start from scratch. For an advanced developer, these tools can serve as a rapid prototyping utility for an automation idea before committing to writing a full-fledged script, or as a handy tool to delegate simple automation tasks to non-technical team members. Diving deeper into how these extensions function, we see a focus on intuitive user experience and visual feedback. The process typically begins with an element selector, a crucial feature that allows the user to point and click on the specific part of a web page they want to interact with. A good selector, like the ones found in Browserflow and Automa, is smart enough to identify a unique signature for that element, such as its ID, class, or text content, making the automation script more resilient to minor changes in the page layout. This step is fundamental, as the reliability of the entire workflow depends on the extension's ability to consistently find and act upon the correct elements on the page, time and time again. Once elements are selected, users build out their workflow by sequencing actions. This is where the visual editors shine. In Automa, you might drag a loop block onto the canvas and place a series of click and extract data blocks inside it to scrape multiple items from a list. In Browserflow, you would add these steps sequentially in a list format. Both allow you to insert delays to wait for a page to load, or conditionals to make decisions based on page content. For example, if the text "in stock" is present, then add the item to the cart. This ability to incorporate logic elevates these tools from simple recorders to genuine automation platforms capable of handling dynamic web environments. UI.Vision introduces another layer of capability that sets it apart. While it also supports standard browser automation through recording and a command-based interface, its standout feature is its integrated visual automation. This means it can find and interact with elements on the screen based on images, not just underlying code. It uses optical character recognition to read text directly from the screen, whether it's inside an image, a PDF document, or a Canvas element that has no accessible DOM structure. This unique feature allows it to automate tasks that go beyond the browser window, such as interacting with desktop application dialogues or handling custom web components that are invisible to traditional automation tools, making it a lightweight but versatile RPA solution. These tools are not just fire-and-forget scripts, they also come with features for scheduling and data management. You can configure a workflow in Automa or Browserflow to run automatically at a specific time each day, for instance, to check for price updates on a competitor's website and log the data into a Google Sheet. This transforms a one-off task into a continuous monitoring system. The ability to pass data between steps, store it in local tables, and export it in common formats like CSV or JSON is what makes these extensions truly practical for data gathering and processing tasks. They effectively provide an end-to-end solution for many common business automation needs, all packaged within a convenient and accessible browser add-on. The collective strength of these no-code extensions is, honestly, their remarkable accessibility and speed of implementation. They empower individuals and teams to automate their own workflows immediately, without waiting for developer resources. This democratization of automation can lead to, significant productivity gains across an organization. Because they operate within a real user-driven browser instance, they often benefit from already being logged into required services and can appear more like human activity to websites making them less likely to be blocked by basic anti-bot measures. The low cost of entry, with most offering generous free tiers, makes them an incredibly low-risk way to experiment with and implement browser automation for light to moderate workloads. However, this approach comes with inherent weaknesses, particularly concerning scalability and robustness. These extensions are fundamentally tied to a graphical browser instance, which makes them less suitable for large-scale, headless automation. Running hundreds of scraping tasks concurrently would require an equal number of visible browser windows, consuming significant system resources. While some services like Browserflow offer a cloud-based execution option, this typically comes at a subscription cost that can add up with heavy usage. For massive data extraction projects involving millions of pages, a code-based framework running on a server is a far more efficient and scalable solution. Debugging and maintenance can also become a challenge as workflow complexity grows. When a visual flow breaks because a website has updated its layout, identifying the exact point of failure can be a process of trial and error. While the tools provide logs and highlight the failed step, troubleshooting can still be more cumbersome than debugging code with a proper debugger. Furthermore, these tools are heavily dependent on the browser they are built for, most commonly Google Chrome. If your application requires rigorous cross-browser testing on Firefox and Safari, a Chrome-only extension will not suffice. This browser-centric limitation is a critical consideration for any serious software testing use case. Ultimately, these tools are not a replacement for programmatic solutions, but rather a powerful complement to them. They excel in scenarios where speed of development is paramount, and the user is not a programmer. They are perfect for small-scale data scraping, automating personal administrative tasks, or enabling a QA team to quickly build and run simple regression tests without writing code. Their integration into larger systems is often limited, though some offer webhook or API triggers on higher-paid tiers. For an advanced developer, their value lies in their ability to quickly solve small problems, or to empower their non-technical colleagues, while leaving the heavy-duty, mission-critical, and highly scaled automation to more robust code-based frameworks. We now arrive at the final category in our showdown, the domain where developers feel most at home: code libraries and frameworks. This is where the true power of browser automation is unleashed, offering unparalleled control, flexibility, and performance. Tools like Microsoft's Playwright and Google's Puppeteer are not applications you install. They are software libraries you integrate directly into your own code. They provide a rich application programming interface, or API, that allows you to programmatically command a browser to do your bidding. This approach moves beyond visual editors and conversational prompts, placing the developer in the driver's seat with the full power of a programming language at their disposal to build highly sophisticated and customized automation solutions. The fundamental principle behind these frameworks is to provide a bridge between your code and the browser's engine. You write scripts in languages like JavaScript, TypeScript, Python, or C#, and these libraries translate your commands into actions that a browser can execute. This could involve launching a headless browser instance, one that runs in the background without a graphical user interface for maximum speed, navigating to a specific URL, interacting with page elements, and extracting data. Unlike no-code extensions, which are limited to a predefined set of actions, a code-based approach means if you can express the logic in code, you can automate it. This opens the door to complex conditional logic, intricate error handling, and seamless integration with other systems like databases or APIs. These libraries were born from the demanding needs of modern web development, primarily for automated testing and advanced web scraping. They are engineered for precision and reliability. When you're building an end-to-end test suite for a complex web application, you need to ensure that every user interaction is tested flawlessly across different browsers and under various network conditions. Similarly, when you are building a data extraction pipeline that needs to process thousands of pages per hour, you require a solution that is both fast and robust. Code-based frameworks are designed to meet these high-stakes requirements, providing the low-level control necessary to build automation that is both powerful and maintainable over the long term. For an advanced developer, working with these libraries feels natural. It means your automation scripts are just another part of your code base. They can be version controlled with Git, reviewed in pull requests, and included in your continuous integration and continuous deployment pipelines. This professionalizes the automation process, turning it from an ad hoc activity into a managed and scalable engineering discipline. Instead of a visual flow that exists in a browser extension, you have a test file or a script that can be executed, debugged, and refactored just like any other piece of software, providing a level of rigor that is essential for mission-critical applications. Within the world of code-based automation, two names stand out as the dominant forces. Puppeteer, created by Google, and Playwright, developed by Microsoft. Both are open source and free to use, and they share a common ancestry. Playwright was actually started by a team of engineers who had previously worked on Puppeteer at Google. Puppeteer was the first to gain widespread popularity, offering a clean and powerful Node.js library for controlling the Chrome and Chromium browsers. It quickly became the go-to tool for developers needing to automate Chrome, especially for tasks like generating PDFs from web pages or conducting performance tests. Its API is intuitive and focuses on providing a direct line to the powerful features of the Chrome DevTools protocol. Playwright, however, was built to address some of the limitations that developers encountered with Puppeteer, most notably in the area of cross-browser support. From its inception, Playwright was designed with a write once, run anywhere philosophy. A single Playwright script can be executed against all major browser engines: Chromium, which powers Google Chrome and Microsoft Edge, WebKit, the engine for Apple's Safari, and Firefox. This is a massive advantage for end-to-end testing, as it allows developers to validate their application's functionality and appearance across the entire browser landscape with a single unified codebase, eliminating the need to maintain separate test suites or use different tools for each browser. This cross-browser capability is complemented by Playwright's multi-language support. While Puppeteer is primarily a JavaScript or TypeScript library, Playwright offers official first-class client libraries for JavaScript, TypeScript, Python, Java, and .NET. This broad language support means that development teams can integrate browser automation directly into their existing projects and technology stacks, whether they are a Python shop doing data science or a C# team building enterprise applications on the .NET framework. This flexibility has been a key driver of Playwright's rapid adoption, as it meets developers where they are, rather than forcing them into a specific language ecosystem to perform browser automation tasks. Another area where Playwright has innovated is in the developer experience, particularly around handling the timing issues that often plague automation scripts. Web pages are dynamic, and elements don't always load instantly. Playwright introduced a feature called Auto Wait, where it automatically waits for an element to be ready for interaction before attempting to click or type on it. This simple but profound feature eliminates a common source of test flakiness and simplifies the code, as developers no longer need to litter their scripts with manual waits and sleeps. Features like its built-in test runner, which supports parallel execution out of the box, and its trace viewer, which provides a detailed step-by-step recording of a test run, further solidify its reputation as a modern developer-centric framework. So, the true superpower of code-based frameworks like Playwright and Puppeteer really lies in their limitless integration and scalability. Because your automation is written as code, it can be seamlessly woven into any part of your software development lifecycle or business process. For a development team, this most commonly means integrating automation into their CI/CD pipeline. You can configure your system so that every time a developer pushes new code, a full suite of Playwright tests is automatically run in the cloud across Chrome, Firefox, and Safari. If any test fails, the build is blocked, preventing bugs from ever reaching production. This level of automated quality assurance is simply not achievable with no-code extensions or interactive AI agents, but this integration extends far beyond just testing. Imagine building a custom application that needs to generate a report by pulling data from 3 different legacy web applications that don't have APIs. With a Python script using Playwright, you can automate logging into each of those websites, navigating to the correct pages, scraping the necessary data, and then consolidating it all into a single database or a PDF report. The browser automation part is just one component of a larger program that can include complex data processing, database interactions, and communication with other services. This ability to combine browser automation with the full power of a general-purpose programming language is what enables the creation of truly powerful and unique solutions. Scalability is another area where these frameworks are honestly in a class of their own. When you need to perform automation at a massive scale, For example, scraping product information from millions of e-commerce pages or running thousands of tests in parallel, you need a solution that can be distributed across multiple machines. Both Puppeteer and Playwright are perfectly suited for this. You can spin up hundreds or even thousands of headless browser instances in the cloud, each running a small piece of the overall job. This parallel execution allows you to complete massive tasks in a fraction of the time it would take to run them sequentially, bounded only by your budget for cloud computing resources. And this scalability is not just theoretical, it is actively used in production by companies of all sizes. Data-as-a-service companies build their entire business on top of large-scale scraping infrastructure powered by these frameworks. Tech companies with massive web applications rely on large grids of machines running Playwright tests to maintain software quality. The cost model is also highly efficient at scale. The libraries themselves are free and open source, so your only costs are the developer time to write the scripts and the cloud infrastructure to run them on. This is often far more cost-effective for high-volume tasks than paying a per-run or per-seat subscription fee for a third-party service. Of course, this immense power and flexibility come with a significant trade-off: complexity and the need for specialized skills. The most obvious weakness of code-based frameworks is that they are completely inaccessible to non-programmers. Building, debugging, and maintaining an automation script requires a solid understanding of a programming language, knowledge of the framework's API, and familiarity with web technologies like HTML, CSS, and the DOM. This creates a high barrier to entry and means that the responsibility for automation falls squarely on the shoulders of the development team. A simple task that a marketing analyst could automate in 10 minutes with a no-code extension might require several hours of a developer's time to script. The initial setup and development effort is also considerably higher. You can't just click a record button and have a working automation. You need to set up a development environment, install the necessary libraries and dependencies, and then write the script from scratch. Debugging can also be more involved. While tools like Playwright's Trace Viewer are a huge help, figuring out why a selector is failing or why a race condition is occurring still requires a developer's analytical skills. This upfront investment of time and effort means that for quick, one-off automation tasks, a code-based solution can sometimes be overkill. Maintenance is another critical factor to consider. Websites are not static, they change constantly. When a website's layout is updated, the CSS selectors or XPath expressions that your script relies on can break, causing your automation to fail. This means that automation scripts require ongoing maintenance to keep them functional. While well-written scripts can be made more resilient by using robust selectors, there is no escaping the fact that a developer will need to periodically revisit the code to update it in response to changes on the target websites. This maintenance burden is a long-term cost that must be factored into the decision to build a programmatic solution. Finally, while these frameworks are incredibly powerful, they are not invisible. Sophisticated anti-bot systems on websites are specifically designed to detect and block automated browsers, including those controlled by Playwright and Puppeteer. While these tools run on real browser engines, headless browsers have certain digital fingerprints that can be detected. Successfully scraping a heavily protected site often requires implementing advanced stealth techniques, such as using residential proxies, rotating user agents, and solving CAPTCHAs, which adds another layer of complexity to the development process. For the most challenging targets, even a well-crafted script can be blocked, which is a risk that must be managed. When we place these three distinct categories of browser automation tools side by side, a clear spectrum emerges, defined by the fundamental trade-off between ease of use and raw power. On one end of this spectrum sit the cloud AI agents, which represent the pinnacle of user-friendliness. Their natural language interface completely abstracts away the technical complexities of browser interaction. A user does not need to know anything about CSS selectors, the DOM, or even the concept of a workflow. They simply state their goal, and the AI takes over. This makes automation accessible to the widest possible audience, turning a complex technical challenge into a simple conversation. It's the ultimate easy button for web-based tasks, designed for maximum convenience and minimal learning curve. In the middle ground, we find the no-code browser extensions. These tools, like Browserflow and Automa, strike a deliberate balance between accessibility and functionality. They lower the barrier to entry significantly compared to code, using visual drag-and-drop interfaces and recorders that allow non-programmers to build structured automation flows. While they require a user to think more procedurally about the steps involved in a task, click here, type this, extract that, they do so within a guided, intuitive environment. This approach empowers a broader range of users to create robust, multi-step automations without writing a single line of code, effectively democratizing a level of control that was once reserved for developers. They offer more power than AI agents but remain far more approachable than pure code. At the far end of the spectrum, we have the code libraries and frameworks like Playwright and Puppeteer. This category sacrifices all semblance of beginner friendliness in exchange for absolute, uncompromised power and flexibility. The learning curve is steep, requiring deep technical knowledge of programming, web technologies, and the specific library's API. However, for those who can climb it, the reward is limitless control. Developers can build anything they can imagine, from highly complex and resilient test suites to massive distributed data scraping operations. Every aspect of the browser's behavior can be fine-tuned, and the automation can be seamlessly integrated into any software system. This is the domain of the specialist, where automation is treated as a serious engineering discipline. Ultimately, this comparison reveals that there is no single best approach. Instead, each category is optimized for a different type of user and a different philosophy of work. The choice between them is a strategic one. Do you need to empower your entire team to automate simple tasks quickly? A no-code extension is likely your answer. Are you trying to solve a one-off complex problem without investing time in development? An AI agent might be the most efficient route, or do you need to build a mission-critical, highly scalable automation system that will be a core part of your infrastructure? In that case, only a code-based framework will provide the necessary power and rigor. When evaluating these tools from a developer's perspective, performance and scalability are paramount. In a raw speed competition for high-volume tasks, code libraries and frameworks are the undisputed champions. Running in a headless mode, stripped of the overhead of a graphical user interface, a well-optimized Playwright or Puppeteer script can execute tasks at machine speed. Their ability to run in parallel across multiple CPU cores or even distributed across a grid of servers allows for massive scalability. This makes them the only viable choice for industrial-scale web scraping, comprehensive end-to-end testing, or any scenario where processing thousands of pages or running hundreds of tests concurrently is a requirement. Their performance is engineered for heavy-duty workloads. No-code browser extensions occupy the middle tier of performance. Running within a standard graphical browser instance, they are inherently slower and more resource-intensive than their headless counterparts. While perfectly adequate for automating tasks that a human would perform, such as scraping a few hundred records or running a daily check on a website, they are not built for massive scale. Trying to run 100 automations simultaneously would likely bring a user's machine to a halt. While cloud execution options offered by services like Browserflow mitigate this by running tasks on back-end servers, likely using headless code frameworks themselves, this introduces a cost factor and moves away from the core in-browser experience, essentially turning the extension into a front end for a paid service. AI agents represent the most unpredictable category in terms of performance. The speed of execution is not just about browser rendering and network latency, it's also dependent on the thinking time of the AI model. The process of analyzing a page, reasoning about the next best action, and executing it can introduce a noticeable delay compared to a hard-coded script. While Opera's local DOM-based approach is likely faster than OpenAI's vision-based cloud model, neither is designed for high-throughput processing. Their scalability is also limited, as they are primarily designed for interactive single-user sessions. You can't easily spin up 1,000 AI agents to work on a task in parallel. Their value is in handling complexity, not in raw, repetitive speed. The cost models for these solutions are as varied as their capabilities. Code frameworks are fundamentally free and open source. The only costs are the developer's time and the infrastructure to run the scripts. No-code extensions operate on a freemium model, with free tiers for basic use and recurring monthly subscriptions, often $20 to $50 or more, for advanced features like cloud scheduling and API access. AI agents are currently tied to subscription services, such as the $20 per month for ChatGPT Plus, with potential future costs based on usage. For a developer or a business, this means a code-based solution has the lowest direct software cost and can be more economical at scale, while extensions and AI agents trade a recurring fee for convenience and a lower barrier to entry. The final and most critical part of our comparison is understanding which tool is the right champion for a specific job. The decision hinges on three key factors: the nature of the task, the technical skill of the user, and the need for integration and scale. To make this clear, let's consider some concrete scenarios. If you are a marketing professional who needs to quickly scrape contact information from a list of 50 websites for a lead generation campaign, a no-code browser extension like Browserflow or Automa is the perfect choice. It's fast to set up, requires no coding skills, and can accomplish the task efficiently without needing to involve the engineering team. Now imagine a different scenario. You need to book a complex, multi-city trip that involves checking flight availability on several airline websites, comparing hotel prices on different booking platforms, and finding rental car options, all while adhering to a flexible budget. This task is ill-defined, requires reasoning, and changes every time you do it. This is the ideal use case for a cloud AI agent. You can simply describe your goal in natural language to the ChatGPT operator, and it will perform the exploratory research and booking process for you. Writing a code script for such a variable, one-off task would be a massive, impractical effort. The AI agent's strength is in handling this kind of ambiguity and complexity on the fly. Finally, consider the needs of a software development team building a large, sophisticated web application. They need to run a comprehensive suite of several hundred regression tests across Chrome, Firefox, and Safari every time new code is committed to their repository. This is the exclusive domain of code libraries and frameworks. Using Playwright, they can build a robust, maintainable, and highly scalable test suite that integrates directly into their CI/CD pipeline. The tests are version-controlled, peer-reviewed, and run automatically, providing the rigorous quality assurance needed for a professional software product. No other category of tool can provide this level of integration, performance, and control for such a mission-critical engineering process. In conclusion, the browser automation showdown does not yield a single winner, but rather a roster of specialized champions. The intelligent AI agent is your go-to for complex personal assistance. The accessible no-code extension is the workhorse for team productivity and straightforward repetitive tasks. And the powerful code framework is the indispensable tool for professional developers building scalable, integrated automation systems. The truly advanced developer understands the strengths of each and knows how to select the right tool from their arsenal, choosing not just the most powerful option, but the most appropriate one for the challenge at hand. Our journey through the landscape of browser automation has revealed a dynamic and rapidly evolving field. We have moved from the conversational intelligence of AI agents to the accessible power of no-code extensions, and finally to the deep, programmatic control of code libraries. This showdown was never about finding a single dominant winner, but about illuminating a spectrum of solutions, each with a distinct purpose and philosophy. The verdict is clear. The best tool is not a title held by one technology, but a strategic choice that depends entirely on the task, the user, and the required scale. The modern web is too diverse for a one-size-fits-all approach, and the ecosystem of automation tools has matured to reflect this reality, offering specialized instruments rather than a single multi-purpose hammer. The emergence of cloud AI agents like the ChatGPT operator and Opera's browser operator marks a revolutionary shift towards intent-driven automation. They excel at handling ambiguity and complex, one-off tasks that would be prohibitively difficult to script. Their strength is not in raw speed, but in cognitive ability, making them powerful personal assistants for navigating the web's complexities. On the other side, no-code browser extensions such as Browserflow and Automa have successfully democratized automation, empowering non-programmers and developers alike to quickly build and deploy solutions for repetitive workflows. They are the champions of productivity, bridging the gap between manual effort and complex coding with their intuitive visual interfaces and rapid implementation cycles. Finally, the code libraries and frameworks with Playwright and Puppeteer leading the charge remain the undisputed kings of power, precision, and scalability. For advanced developers, these tools are not just utilities, they are integral components of the software engineering lifecycle. They provide the only viable path for building robust enterprise-grade testing suites and large-scale data extraction pipelines that demand high performance and deep integration. The control they offer is absolute, but it comes at the price of complexity, requiring a significant investment in development and maintenance. Understanding this trade-off is the key to leveraging their immense capabilities effectively and responsibly within a professional development context. In synthesizing these findings, we see a complementary, not a competitive, ecosystem. An AI agent can help a developer quickly research a new API, a no-code extension can automate the tedious task of populating a test database, and a code framework can then run the mission-critical regression tests against that database. The truly effective developer or team will not pledge allegiance to a single category, but will instead build a versatile toolkit, recognizing the unique value proposition of each. The future of browser automation is not about choosing one path, it is about knowing which path to take for each specific journey you embark upon on the web. Based on our comprehensive analysis, our recommendations for advanced developers and their teams are direct and action-oriented. First, embrace a hybrid approach. Do not view these tool categories as mutually exclusive. Equip your team with access to a no-code extension like Automa or Browserflow. Use it for rapid prototyping of automation ideas, and for empowering non-technical team members, such as QA analysts or product managers, to automate their own repetitive tasks. This frees up valuable engineering resources from low-impact requests and fosters a culture of efficiency across the entire organization. The small subscription cost is often a negligible price for the significant productivity gains it can unlock for the whole team. For your core development and testing processes, we strongly recommend standardizing on a code-based framework. Given its superior cross-browser capabilities, multi-language support, and modern developer-centric features like auto-weights and trace viewing, Playwright stands out as the forward-looking choice for new projects. It provides the robustness and scalability required for building mission-critical end-to-end test suites that integrate seamlessly into your CI/CD pipelines. While Puppeteer remains a solid choice for Chrome-specific tasks, Playwright's versatility offers a more future-proof and comprehensive solution for ensuring application quality across the entire web ecosystem. Invest the time to build maintainable, well-structured automation code. It is a foundational element of modern software quality. Regarding the emerging AI agents, our recommendation is to treat them as powerful productivity enhancers for individual developers. Use ChatGPT operator or similar tools to accelerate research, perform ad hoc data gathering, or handle complex, non-repetitive administrative tasks on web interfaces that lack APIs. Think of it as a pair automator that can handle the tedious clicking and form filling while you focus on higher-level problem solving. While they are not yet ready for integration into production systems, their ability to understand natural language and adapt to new interfaces makes them an invaluable tool for reducing the friction of daily, non-code-related web tasks that consume precious time and mental energy. Ultimately, the strategic developer views browser automation not as a single problem, but as a spectrum of challenges requiring a spectrum of solutions. Your primary mission-critical automation should be built with the rigor of code using a framework like Playwright. Your team's day-to-day productivity for simpler, repetitive tasks should be boosted by the accessibility of no-code extensions, and your individual workflow for complex, one-off web interactions should be accelerated by the intelligence of AI agents. By strategically deploying the right tool for the right job, you can maximize efficiency, improve software quality, and free up your most valuable resource, your time, to focus on building the future.